ICT Technology, Chichester H. Apostol. Compression Attached Memory Module. It was revealed through leaks earlier this year that Dell have been developing the next generation of DDR memory for several years, called Compression Attached Memory Module, CAM, to replace sodium on laptops. Dell Compression Attached Memory Module is what the company intended will become a new JEDEC, Joint Electron Device Engineering Council, set guidelines for memory speed, timing, and voltage, standard to the augment or replace sodium memory in laptops and other small computing devices. CAM versus sodium.
This is the CAM module, or Compression Attached Memory Module, and looks pretty cool, I guess. But why? Well, currently the memory in your laptop is probably more like what's in this XPS 15. SODIMM, or Small Outline DIMM modules, have been around for 25 years, and that's one heck of a run for technology. But with the speeds we're expecting to see in the coming years, they're simply running out of gas. Why? Good old signal integrity. The longer the wire, the greater the signal loss and the greater the latency. Look at the fastest memory products on the market. HBM, or high bandwidth memory, is mounted right on the package mere millimeters away from the processor that it serves. The GDDR6 memory on a 4090, all of that is within a couple centimeters of the GPU die. This keeps the wires as short as possible. By comparison, the chips on a SODIMM might as well be in Narnia with a minimum wire length of around 7.5 centimeters. This is super easy to see on our XPS 15. The CPU is soldered to the motherboard right here, then the traces need to travel all the way underneath these memory modules, back up through the connector, and then around finally into the package dies. There are DDR5 SODIMMs in laptops, however, if you've been paying close attention, you've probably noticed that machines with soldered RAM have been enjoying a speed advantage compared to their SODIMM-equipped competitors. For current gen DDR5, it's not an insurmountable problem. The theoretical max for SODIMM is about 10,000 megatransfers per second, but it's already proving to be pretty difficult in the real world to get those kind of speeds, and DDR6 will definitely surpass even that theoretical limit. You're probably wondering why we can't just simply turn these SODIMM connectors around. That's a good question, and our best guess is that it just becomes impractical to pack enough zigzagging traces in this small little area so that every single wire is the same length, something that is crucial to maintain perfect signal timing. Now let's turn our attention to CAM. We've got the CPU right here, and the connector, yeah, you can't get much closer than that. Even with the largest CAM modules, we're looking at a 50% reduction in distance to the CPU. That is fantastic. But there's another big reason laptop manufacturers have been soldering down RAM: physical size. If you're looking to make the thinnest and lightest machine you can, the SODIMM connectors can easily end up being the tallest component on your motherboard. So if even a couple of millimeters can be saved by soldering down that RAM, it's gonna happen. Unfortunately, such devices are completely unupgradable and very difficult to repair. Thankfully, CAM removes that excuse as well, or at least helps mitigate it. On top of supporting much higher memory speeds, CAM is 57% thinner than SODIMM. That helps not only keep devices thinner, but even helps facilitate better airflow over the memory packages. Back to speed for a second. For the moment, CAM only has a speed advantage at 128 gigabytes of RAM, but Dell wasn't trying to set any speed records on its first outing. Annoyingly, the business users that use the Precision lineup want stability instead of all-out performance, so we'll have to wait until CAM shows up in Alienware or something to see how fast it really can go.
Sodium, designed 25 years ago, can already affect DDR5 implementation, and do not mention what they do to the upcoming DDR6 standard. Dell posits that sodium may not be able to scale past 6400 NTs, but there are several other reasons CAM is important for the laptop industry. Dell CAM avoids sodium bandwidth limitation by using a compression connector. The benefits are already apparent with higher capacity modules RAM module scales from 16 gigabytes to 128 gigabytes. The 128 gigabyte modules can run at DDR5 4800, where DDR5 sodium only scale to 32 gigabytes. In that configuration, thus, the benefits of RAM can already be realized at high end, both in terms of footprint and performance. RAM also reduces laptop design complexity, especially in laptops that would traditionally use four sodium slots. The illustration below show in the situation COM eliminates the needs to put memory on both sides of the motherboard. This means thinner laptop with more overall room for components. Advantage of COM. The COM module is much larger in the square inches than a sodium. But there are upsides. Implementing four sodium in a laptop typically required using both sides of the motherboard, adding to the thickness and complexity. A single CAM module scales to 128 GB as noted and would take less space and thickness than four sodiums. Thank you for listening.